Example 4 on page 425. Find the LCM of x squared minus y squared, x to the third power plus y to the third power, and x squared plus 2xy plus y squared. So there are three expressions, and we're looking for the LCM. Again, to find LCM, you need to find factors from these three expressions and use the factor with the highest degrees, which means the highest number of times that the factor occurs. All right, let's factor out each expression. The first expression is x squared minus y squared. Now, when you see x squared minus y squared, you know we learned a formula that's similar to this, a squared minus b squared. When you see this, you know you can factor this out to a minus b times a plus b. Okay? So I'm going to use this formula. X is a, so a minus b means x minus, what is b? B is y squared, right? After the subtract, so b is y, a, which is x, plus b, which is y. So this first expression can be factored to two terms, x minus y times x plus y. So we're done with the first expression. How about the second one? Second expression is x to the third power plus y to the third power. We need to factor this out. Now, we learned this before. We know that you have a formula, a to the third power plus b to the third power can be factored to a plus b time x squared, time a squared subtracts, this is subtract, okay, ab plus b squared. Now, you can choose to memorize and factor this out this way, or you just have to check, if you're uncertain about this, you can multiply this a to the second factor, this b to the second factor, simplify, you would get this formula, okay? Again, I obtained this right-hand side from using the formula. So just memorize that and you know how to factor this out, okay? So a to the third power is x to the third power, right? So a is x, okay? So a is x, okay? How about b? After b, right? After pause, right? So b is y, okay? This can help you when you apply these factors here. All right, so we have a plus b, right? A plus b, a is x, so x plus b is y, right? How about this one? A squared minus ab plus b squared. A is x squared. Subtracts a times b is x times y, okay? Plus b squared. B is y, right? So b squared means y squared. Okay, so I just use this formula to factor out this because they'll have the same format. All right. So for this, we're done with factor out the second expression. Now let's factor out this third expression, x squared plus 2xy plus y squared. This is a trinomial with both x and y. Now, do you see that x squared, y squared? When you see this is review, okay? We worked on this before. So just write this, okay? And x squared, right? That means x times x. So make sure you have x happen in both parentheses, okay? We don't know the sign yet, okay? But we do also have y squared. Y squared is y times y. So make sure you have y in each parenthesis. So y, let's go here. like go here. Okay? Now we don't know the psi or the constant yet, but you see that C is something, C is 1, right? So factors of C, right? So C is 1, 1 times 1 is 1, right? 1 times 1 is 1, so the factor of C is 1 and 1 only. Okay? So factor of C is just 1 and 1. Now, let's see. C has the psi positive, right? It's positive. If it's positive, you know that factors of C will have the same psi. So we'll have the same psi as B. B psi, the psi of B, 2 right here, which is positive, right? So you know that B2 factor of C will be positive. Okay, one more time. Since C, which is 1 right here, the coefficient of this term, C is equal to 1, right? 1 times y squared is y squared. So the coefficient is 1, and 1 is positive. If C is positive, that means the factors of this C, which is 1 and 1, will have the same psi as B. For this term, B is 2. Okay? Psi of 2 right here in positive, that's why the psi of the two factors of C going to be positive, positive. For this, we sum of factors of C, okay? Sum all the factors of C. So this side positive, so sum 1 plus 1 is 2. So I'm going to use, now by the way, we want the sum of factors of C to be equal to B, which is 2, okay? And yes, after we sum up the two factors of C, okay, we get 2. So that's a good thing, because they match. So I'm going to use the two factors of C, okay? 1, 1, here, 1, 1. Let's see, because the psi positive, right? So you positive. All right. I always recommend you to double check, because this is just trial and error, okay? So I don't know if this one correct yet, so make sure you double check. So let's double check. X times x is x squared, right? So we get this term. Y times y, right? 1 times y is just y. 1 times y is just y, right? So y times y is y squared. So we did get these terms. X times x is x squared. Y times y is y squared. The one we need to check is this term. And we can find out about this term by doing this. Take this times this, you get x times y. Okay, or y times x, or x times y, the same thing. And you do the same thing for the outer right here. X times y is x times y. Then you sum up. You take this x times y plus x times y. We'll clear this out. And you take this x times y. You add with this x times y. You get, because they're common, right? They're like term. You know you can combine them. X times y plus x times y is twice the x times y. Alright, guess what? We got this from now. They match, right? So you know that you obtain the correct factors for this third expression. So, alright, now we're done with factoring out all these three expressions. And we're ready to find LCM. Again, to find the LCM, you use the factors from all these three expressions and use the factor with the highest degrees. Alright, let's start with coefficient first. This coefficient is 1. Coefficient is 1. If coefficient is 1, you don't need to write it, okay? It's just 1. If you want, you can do it, but you don't have to. How about x minus y? Let's look at this factor first. So I'm going to look at this one. So x minus y. Is there x minus y here? No. How about here? Is there x minus y here? No. So x minus y only happened one time. Okay? Because x minus y to the first power, okay, it's happened to the first power one time. And it's only happened in this first expression. even though x minus y does not belong to the second factor or the third factor, sorry, even though x minus y factor does not occur in this second expression or in this third expression, you still need to include it, okay? So I'll include here x minus y. I'm not going to write the 1 here, because you know one time this x minus y is still x minus y. Now, x minus y has only happened one time, right? You see, to the first power, so you don't need to include a power, understood as x minus y raised to the first power. Then look at this x plus 1. Is there x plus 1 here? Yes. This x plus 1 happened one time to the first power. This x plus 1 happened one time to the first power, okay? Is there x plus 1 here? Yes. Do you see that? For this x plus 1 happened twice. So x plus 1 happened one time in this first expression. X plus 1 happened one time in this second expression. X plus 1 happened twice in this third expression. So this third expression is the one that we're going to use, okay? So we'll use this x plus 1 in this third expression because this third expression has x plus 1 with the highest exponents, or with the highest number of times that this x plus 1 term occur. This x plus 1 factor occur. So I would have x plus 1 factors, okay, twice, happened twice. So x plus 1 happened twice. Alright, we're done with this, we're done with this. We're done with one term here. We're done with the third factor, okay? The remaining is this one, this factor right here. Now, by the way, every time you see this formula, x to the third power plus y to the third power, when you factor this out, now this, I agree that it does look like a trinomial, and your tendency that you want to factor this out, right? But unfortunately, when you factor out, when you use the formula, okay, when you use the formula to factor out this second factor right here cannot be factored any further, okay? So that's a good news. So if you use the formula to factor out this second expression in this form, x to the third, plus or minus, doesn't matter, y to the third power, if you use the formula, guaranteed, this second factor right here, the trinomial, cannot be factored any further. So just leave it as is. And this factors only happen one time in this second expression, and it does not occur in this first expression or third expression. So I would include this x squared minus xy plus y squared. Okay? And let's see how. And then this is how you factor out, okay? These factors belong to the LCM, and the answer is this. You can write this as the answer, or you can write this as the answer. This is the equivalent form, okay? I want to write this because to match the answer in your book. X plus y happened twice. So you write to the second power, and x squared minus xy plus y squared. Okay? This is how you solve it. This is the LCM. All these three factors are LCMs of these three terms. Okay?